Okay, so hi and welcome. Can you hear me? Okay, so just we are waiting 1 or 2 minutes for joining all of the other participants, then we'll start. Okay, so just we're waiting some time for joining all of those other participants, then we'll start. Okay. Okay, so let's go today's session. So basically today is our seventh number of class, and basically today I will try to discuss about that change detection, how we can easily perform the change detection analysis, mainly NDVI change detection or NDWI change detection, as well as the land use land cover change detection. Okay, so how we can easily perform the land use land cover change detection, as well as how many class or how many area will be transition. Okay, how we can easily calculate the transition area. So this type of analysis for today's class I will try to cover. So let's go. Just I simply share my screen. Okay, so now can you see my screen? So it's visible.
Yes.
Okay,
Yes.
okay, so let's go. Okay, so let's go. Okay, so basically here you can see here I already create the land use land cover classification map for 2 time period. Okay, so just I simply create this map. You can see I show you the result about that. One is that land use land cover map for 2021, and another one is the land use land cover map 1991. Okay, so two types land use land cover classification map I created for this region. So now from here, I calculated what is the change between the 2 time period or 2 decade. What is the change between the year of 1991 to 2021? How much area will be increasing or decreasing? Okay, how much area will be suppose build up area? How much area will be transition zone? Okay, or transition area. So this type of change detection, how we can easily perform using the Google Earth Engine platform. I also try to discuss about this topic one by one, as well as we also try to discuss about the change detection, mainly NDVI change detection. Suppose here you can see, here I already create about the NDVI map using the Landsat top of atmospheric satellite images. So mainly here you can see this is the NDVI for 2020 and another NDVI map for 2015. Okay, two NDVI map I created in here. So now from here I just calculated the change detection between the 2 time period about the NDVI and also calculated the change area. Okay, as well as how we can easily perform the land use land cover change detection. For that I use this map here. For that I already created the 2 time period land use land cover classification map in here. So just in this time we talk about the change detection. Okay, so first of all I discuss about this code. So here you can see here I already created the land use land cover NDVI map. Okay, suppose you can say I simply take the point or polygon about that area and then take the Landsat 8 satellite imagery top of atmospheric. Okay, and from this image I simply filtered the image for year of 2015. Okay, year of 2015 I filtered the image and take the least cloud covered images. Okay, using the short function and take the first. Okay, so it's the filtering process. Further I take the least cloud covered image using the short function and use the fast function. Okay, and then this is my image for 2015. Okay, so further using the image 2015 I compute the normalized difference vegetation index or NDVI. So for that very easy way, so first of all basically this image 2015 it contains all of those band. If you want to check, suppose I simply print this image 2015, it contains all of those band such as B1, B2, B3. Okay, all of those band it available in here. You can see the bands, total 12 bands. So all of those band is available in here. In this time I calculated the NDVI. So I need the 2 band only for the near infrared band and red band. I need only for the red band and near infrared band. Calculated the normalized difference of NDVI. So for that, what can I do? I just take a variable name near. You can use any variable name, no problem. You can take any variable name. After that, call this image 2015 because it contains all of those band. Okay, you can see it contains all of those band. So just I simply copy the variable name image 2015 and paste here and use the function select function. Okay, just use function select function. So using the select function, I select the specific band. In this time, I need the B5 band, which is the near infrared band. Okay, so this is the image 2015. It stored all of those band from I just select the band 5, which is the near infrared band, and all of and this band I stored in a variable near. Okay, same approach for the red band. Just I simply call the image 2015 because this variable stored the all of those band. From I just simply select the band 4. Okay, so now band 4 is stored in the red variable. Okay, you can use any variable name. So now what can I do? Just I simply take a variable, suppose NDVI 2015. Just I simply put my equation near infrared subtract with red, then divided by near infrared add with red band. Okay, so just our formula near minus red divided by near plus red. Okay, and then you can see what is the near. I already defined the near. Near is the band 5. Okay, it stored the near infrared variable. Okay, so near I already defined. Red, what is the red? I already defined the red. Red is stored at the band 4. Okay, so just I simply put my equation and calculated the NDVI for year of 2015. Okay, so now display the result. So just I simply show the result is that visualization parameter -1 to +1 and put all of those color plated and use here the map.layer function, then call the NDVI 2015. I want to display the result for 2015 and then put the visualization variable name. So basically it's the visualization variable name. It is stored in this variable. Just simply copy and paste here and then give a layer name. In this time it's showing the layer name. You can see image NDVI image for 2015. Okay, we can get the result in here. Okay, so this is the one part is completed. So after that we have to calculate the NDVI image for year of 2020. Okay, so at the same time we are also filtering the image for 2020. So for that I simply use a function, you can see filter date, and put my specific time period. And from the year of 2020, I get for the lowest cloud cover image using the short function and fast function. Okay, I can take the lowest cloud cover images. And using the image same, I simply select image 2020 and select the band 5 and also select the band 4. Same approach I also apply for year of 2020 and calculated the NDVI for 2020. Okay. So now in this time, first of all, I need to display the result. So just I simply display the result in NDVI 2020 and visualization parameter name and put also layer name 2020. So now you can see display the result for NDVI map for 2020. So now I can get the 2 time period NDVI map. So now from here, I just need to calculate it, the change detection between the 2 NDVI map and also make the change detection map as well as also calculated the change area. How much area will be changed for the NDVI. Okay, in this time after calculating the NDVI we just simply use a function, subtract function. Okay, just take a variable. You can use any variable name. I simply put the variable name, suppose changed. Okay, so in this variable I simply put here the NDVI 2015 and then subtract with 2020. Okay, so NDVI 2015 subtract with 2020. And after that, I show the changed NDVI map between this time period. So for that, click to the run again. So run the map. In this time, it calculated the change between the 2 time period, NDVI 2015 and 2020. In this time, it get the another layer about the change NDVI map. You can see. Okay. So in this time, it displays the result about the change NDVI map between the 2 time period. Okay, 2015 to 2020. Okay, just subtract pre and past. Just simply subtract in here. So 2015, okay, and 2020. Just subtract. So now we can get the changed NDVI map. So now I want to calculate the changed area. For calculating the changed area, we have to apply a threshold. Okay, so we have to set a thresholding technique. Suppose in this time I calculated the area, suppose greater than 0.2 or less than 0.5, all of those area. So using this range or using this threshold, how much area will be changed for NDVI? Okay, so basically you can see it's only for the one band or one band for NDVI. Okay, so for that in this time, when you want to make the change detection such as NDVI, NDWI, EVI, SAVI, or which contains only for the one band, then we have to set the thresholding. Okay, we have to set a range of pixel value and then calculated the change area. Okay, so otherwise it's not possible. But when I do the land use land cover change detection, then we did not set any types of thresholding. Okay, so in this time it lot of you can see you can take the class water, build up, vegetation, others. So in this time we can easily make the change between the water to water, water to build up, water to for vegetation, water to others, as well as also same. Suppose build up to water, build up to vegetation, build up to others. Okay, so you can do this. So in this time we did not take any types of thresholding. But when you want to work for only for the specific band, such as NDVI, NWI, or EVI, or SAVI, anything. when you want to make the change detection and calculate the change area, for that you must take the threshold. Okay, in this time I put the threshold such as 0.2. Suppose I put the threshold as a 0.2, take a variable var and put the threshold 0.2. After that I have to make a equation or thresholding technique about that. Suppose in this time I just simply change. Okay, in this time it's 0.5 I put it. Suppose I put it the 0.5. Okay, no problem. We can put the any thresholding about that. In this time I calculated the area using this range such as change less than equal 0.5 or change, suppose in this time put here the greater than 0.8. So within this range, suppose 0 less than equal 0.5 or greater than equal 0.8. So using this range or using this pixel range, how much area will be changed between this two time period, year of 2015 to 2000, suppose 20. Okay, so less than 0.5 or greater than equal 0.8. So using this range, how much area will be changed? In this time we calculate about this area. So in this time I just simply call the changed this variable and put at the less than equal 0.5 or change greater than equal 0.8. So in this time we can get with this range about this NDVI pixel value, and from that we need to calculate the pixel area. So using this condition, how much area will be changed for this two time period, year of 2015 to 2020, we have to calculate that. So for that just take a variable pixel area. We simply take a variable pixel area and then simply call the changes. Okay, this variable stored this thresholding. Just I simply copy and paste here, and this I need to add with my function ee.image.pixel area. So this is the function, is calculated the area as a square meter. Okay, so if you want to simply copy this function and get the details information about that, ee.image.pixel area. So mainly it need when you want to calculate the raster image or this type of pixel value or pixel area. When you want to calculate the pixel area, then we have to use the image.pixel area, this function, and this function mainly calculated the pixel in square meter unit. Okay, so in this time I want to calculate this area within this condition. What is the area? Then I simply call this variable name changes and multiply with ee.image.pixel area. Okay, and after that in this time I just need to calculate the value. Okay, suppose in this time it just show the connecting this function but not calculated the numerical value. Okay, it calculated the value is the square meter, but when I want to display the result as a numerical value, then I have to use the another function, this function called the reduce region function. Okay, so in this time further I take the another variable, suppose area, and call the pixel area because it is stored in here. I want to calculate the numerical value. So for that call the pixel area and use the function reduce region function. So first of all, reducer, I want to calculate the total area. Okay, so just use here the e.reducer.sum and also geometry. So basically it's your variable name. Suppose it's your suppose point. Okay, in the point, or in this one we are using here the polygon about that, or any region. Suppose any specific region, you can simply select that. So in this time I simply use here this my boundary and scale. Suppose scale is the 30 meter about that, and now print this area. So now click to the run. So now we can see we can get the result look like that. In this time we can get the result is a square meter unit. Okay, so in this time it calculated the result only for this boundary. Okay, only for this boundary we can get this result in here, only for this boundary. Okay, only for this boundary how much vegetation will be changed between this thresholding. Okay, 0.5 to 0.8, how much vegetation will be changed in here. So now I can simply suppose take the, I want to convert it as a square kilometer. So very easy. This is my number. Okay, so use here the e.number. So use here the e.number, and this number mainly stored in this variable area. Okay, so use here the area, and this area get from this NDVI. Okay, so just use here the get and put here the NDVI. Mainly in this time you can say NDVI. So just use here the NDVI and divide it with the 1 is 6. So then it will be calculated the area in square kilometer. So now click to the run. Okay. So now you can get the result. You can see 1644 square kilometer. Okay, change, vegetation change about this from year of 2015 to 2020. We can get the result look like that. So this is the process you can apply when you want to make the change detection for a specific suppose only for the one band image. So in this time it's only for the NDVI. So for this we have to set the thresholding, and after that using this thresholding, how much will be changed between the two time period, year 2015 to 2020. Okay. So now you can have any question, you can ask me about this code. Anyone any question or any doubt?
Hello.
Yeah, please.
Hello.
Yeah, I can hear you. Yeah.
Sir, I didn't get that please share your screen.
Yes, sir.
Yeah. Sir, this 47 line, 47 variable changes. Sir, why this means specific point zero 0.05 and point zero 0.08 means what is the practical meaning of that? What we are getting with this point zero 0.05 and greater than point 0.8?
Okay, so just I simply show you the NDVI range value. Suppose NDVI range okay. So mainly you can see here the NDVI values range from +1 to -1. Okay, and areas of barren rock, sands, or snow usually show very low NDVI values, almost 0.1 or less 0.1. And sparse vegetation such as shrub, grassland, or sensing crop may result in the moderate NDVI values 0.2 to 0.5. Okay, this is the range about that. And highly vegetation showing the results 0.6 to 0.9. So using this condition, suppose you want to display the result less than in this time, you can see here. So suppose you want to show the 0.2, 0.5. So this range is mainly showing about the result of and also grassland greater than equal 0.8. Okay, so using this threshold, so less than 0.5, less than equal 0.5, and greater than 0.8. Suppose this range which feature or which we can identify from here which feature. So mainly you can see the 0.5 to 0.8. Okay, so 0.6 to 0.9. So in this time 0.5 to 0.8. So this time we can get the suppose high NDVI values. Okay, which means about that vegetation or dense vegetation or trees. This type of things we can get from here. So in this time, we just show the result about that 0.5 greater than 0.8. So this range, suppose 0. Greater than 0.8. So we can get the highly vegetation, and less than equal 0.5. From less than equal 0.5, we can get the suppose shrub or grassland or sensing crop, this type of vegetation. So 0.5 to 0.8. So mainly this range, we can get that 0.8 less than equal 0.5 to greater than 0.8. So between this range, we can get the vegetation. Okay, suppose dense vegetation, all of those suppose shrub, grassland, this type of feature we can get. So that's why we are using here this type of range 0.5 or greater than equal 0.8. So in this time, it makes the thresholding using this range and store it in this variable.
Sir, but we did not apply this formula on actual NDVI. We applied it on changed map. So change map itself is subtracting 2020s and 2015 NDVI values.
Yes,
If
yes.
suppose a pixel of 2015 and of in same pixel in 2020 having same NDVI, so this subtraction will give us zero value on that pixel.
This one?
Suppose we are applying the 47th line differences
Yes.
on the difference image, means on changed image.
Yeah, change.
Okay.
Yes.
But change image itself is a subsection of two images.
Yes.
Means 2015 minus 2020.
Yes.
Suppose in a pixel of 2015 image having NDVI of 0.2, okay,
Yes.
and same pixel in 2020 having also 0.2 NDVI.
Yeah. Then
So
we can
this
get the zero.
subsection, yeah, it will get zero. Changed image of that pixel will be getting zero value.
Yes.
So if we are applying this function, 47th function on the change image, then I'm means little bit confused that if we are applying range on the original image, then it is okay. I am able to understand. But on the changed image, because it is subsection of two image, the actual values means it is not that if there is a subsection is zero, then we cannot say there is no vegetation,
When
because
get the value for the zero, it means that there is the no change. Suppose I can get the 0.2 2015 and also get the 0.2 for 2020. Okay. So both value is the same. So it means that there is the no change. Okay. So when I can get the zero, it means that there is the no change between these two time period. I can get the same pixel value. So that's why it's showing that there is a no change about the value. Okay.
okay, or any pixel which will be getting negative value of NDVI. Suppose in 2015 it is 0.2 and in 2020 it is 0.3, so and then subsection will give minus 0.1.
Yeah, then it will be converted into the other features.
Okay.
Suppose it will be converted into the water. It happens. Suppose in this time here you can see the changed image. In this changed image we can get the this type of color. Okay, suppose you can see. So first of all it will be water, but when I want to make the changed map, we can get the red color. So red color is identify about the for that it will be just deposition of sand on this river. So here you can see it's not a vegetation. Okay. So it deposition of the sand or barren or rock, this type of feature in deposition in here. Okay, so it will be changed about that. Okay, suppose we can get the pixel value, suppose negative in here. After suppose painting the two dictate, we can get the negative. So then it means about that it will be also change the feature about that. Okay, suppose it will be water or vegetation. Now it convert into the suppose barren. Okay, or it different on the pixel value. Okay.
Sir, but one more question, means what is the practical application of this NDVI change? Means okay, we are getting, because sometime if 0.1 value change in NDVI will give the change map. Okay, means other than zero, all will be pixel greater than zero, less than zero. There is something change.
Yes.
Okay, but it may be happen that sometimes NDVI value for a spare vegetation is suppose 0.123 is there, and after change it is getting 0.124. So is that practical meaning because NDVI is differing after 2 decimal point or 3 decimal point? So
you can see the range. Suppose you can see for this point we can get the NDVI value is the negative. First of all 2015 we can get the 0.2. Okay, so after that you can see for the 2020 you can get the 0.4. Okay, so after that we can get the negative 0.7 in here. Okay, suppose in this time zero, suppose zero it's identify about the water. Okay, after water, and 2020 we can get the suppose low vegetation about that. And when I want to make the change detection, then we are also get about that 0.7 between these two time period. Okay, two time period it turn into the 0.7 pixel value. Okay, we take about that suppose water. Okay, not for the vegetation, So in this time our main target is that I find out the vegetation change. Okay, NDVI mainly we use here for the vegetation change. So that's why we use the threshold. Suppose in the change area I don't concern about the water body, barren land or other feature. My main concern is only for the vegetation. What is the change? The vegetation. So for that from the changed, I extract only for those vegetation range. Suppose less than equal 0.5 or greater than equal 0.8. Okay, so mainly these two things. Suppose from these two things, suppose in this time I can get the 0.7. So it's not the vegetation pixel value. It's not a vegetation pixel value. Suppose my main concern is only for the vegetation. How much vegetation will be changed, or how much vegetation will be I can get for in here between this two time period. So for that, I simply call the changed, and because it contains, you can see 0.7, but I don't concern about the 0.7. I take only for the positive value, such as less than equal 0.5 or greater than equal 0.8. So between this range, what is the condition about the NDVI from the changed? I want to calculate about that.
Sir, but taking less than equal to 0.5 means the values which are lower than zero point 0.5. Okay, means it could be 0, it
No,
could
no.
be
In this time,
0.1.
you can see the OR function. Okay, so and or these two types of function you can get. Suppose when the two condition is the true, then accept. Suppose and function or function, it is the another meaning. Suppose when I use the another function, suppose and function, then it also calculated the another value. Suppose when I use the or function, it calculated the another value. So in this time, when I use the or function, when this is true, then it accepted. Okay, just taking about the greater than 0.8, all of those values. Okay, suppose in this time, so it's mainly our comparison operator. Suppose and or nor. Okay, and this type of function we are using here. So in this time, which condition is the true? Suppose one condition is the true, then it will be accepted, and then make the result about that. Okay, okay, so I show you the suppose
Okay.
some example. Suppose you can see and or or function return true if any of its the argument evaluate the true. Okay, and return false if all the its argument evaluate the false. Okay, so the or function return the true if any of its argument evaluate the true. Suppose in this time anyone is the true, any one condition is the true, then it will be evaluate this result, we can get the true. It means that it take the value about that. Okay, so in this time we are using the or function. So that's why it when it will be greater than equal 0.8, it extract this pixel value and make the self marks and calculate the area about that. Okay, so in this time less than, suppose in this time for my region 0.5 is not available for this pixel value, but greater than 0.8 is available. So this condition is the true. So then it will be extract all of those pixel value greater than 0.8, greater than equal 0.8, and then make this calculation.
Sir, but in this case, 0 will be available in that pixel. Okay.
Yes.
So 0 is less than zero point 0.5. So this condition will be true, and that pixel will be taken in this change image.
0. Okay, please.
Yeah, yeah. This means we are giving the condition. One condition is less than zero point 0.5, less than equal to zero point 0.5. Means if the pixel value is 0, then that pixel will be taken in this change image. Means in this calculation, because the condition is meeting. It is
Yes.
0 is less than zero point 0.5. But we are not concerned about change means 0 pixel means not change area. But in this case, it is taken there here.
Okay, for that we are also put here the suppose 0.8. Okay, less than equal 0.8 or greater than 0.8. So now check the result.
Sir,
So it will change about that. You can see within this range we can get the less than equal greater than equal 0.8. suppose you can put at the suppose not only for this, so any condition, suppose you want to take only for the specific piece time, you can simply from the change you can get suppose change greater than suppose 0.5. Okay, so now in this time it is variable stored all of those pixel value greater than 0.5. Okay, and then calculate this area for the 1.89 square kilometer. Suppose you can any specific, suppose greater than 0 point or greater than equal, suppose greater than equal